And now for the promised conclusion, the proof that principal G-bundle is a gerbe. PG is a gerbe. So what were again the conditions we have to satisfy? Number 0, PG has to be a stack. Why is that the case? Well, it's actually pretty similar to vector bundles. As I mentioned earlier, we can construct a principal bundle from local data. Similarly, we can also construct morphisms of principal bundles from local data. And that is exactly what we need for a stack. Check. Number 1, for every manifold M, PG of M is a groupoid. In other words, it is a stack in groupoids. Well, yeah, we've also seen that. Number 2, it has to satisfy a certain non-emptiness condition. Well, the condition says that every manifold, every object of our site have a cover such that on this cover there exist principal bundles. In this case, we don't even need a cover. For every M, PG of M is non-empty. And why is that the case? Well, we can just take the trivial bundle M times G, and that one is a principal G bundle over M. Check. And number 3, for every manifold and for every 2 principal bundles, so PQ and PGM, there is a cover of M such that the morphisms in the category of principal G bundles over, well, now UI, between P restricted to UI and Q restricted to UI is non-empty. And why is that the case? Well, when we look back to our definition of a principal bundle, we had the cover UI of our manifold M such that when restricted to these UI, our principal bundle is isomorphic as principal G bundles to the trivial bundle UI times G. Well, we can just take a trivializing cover for P and for Q and then sort of take intersections so that we have a trivializing cover for both P and Q. And then when restricted to these open sets, P and Q become trivial over the same manifold, which means that they are isomorphic. So there exists in particular a morphism between them. So that is also satisfied. All in all, we conclude PG is a gerbe.